Thank you guys very much for joining the talk here. Bitmovin was invited to speak about high-speed encoding, and we figured we'd use the time to talk a little bit about an impending problem that we see coming. So is your encoding load about to explode? So we think the answer is definitely yes, and I'll explain to you why, because I think there's a lot of people that understand this and some people that don't understand the impending problem. So let's talk a little bit about the problem that's coming. So first we'll start with just the stuff that everybody already knows. Online video traffic keeps growing. Nothing that you guys don't know, but it's growing at an increasingly fast rate. So if you look at the last 3 years, it's grown almost at 100%. But if you look at what's forecasted over the next 3 years, it's growing at even faster than 100%. So it continues to go up, and at some point there will be an inflection point in which we'll see a lot more. In addition to that, we see video getting much larger, right? Another thing you guys probably don't know, we're moving from kind of standard HD to 4K. We're already starting, even though 4K is just barely getting deployed, we're already starting to hear a lot of people talk about 8K. HDR is something that a lot of people are deploying. VR is starting to take off. So there's a lot of things that are making the files bigger. More video, bigger files are things that everybody knows is coming. The thing that most people maybe don't know is that the way most people are addressing this right now is by using better codecs, right? So all the PhDs that get paid a lot of money to develop better codecs are moving to HEVC and VP9 and AV1, and these compression codecs do a much, much better job at delivering high quality video with lower bandwidth rates. So they're solving that problem, because we all know there's going to be a problem with all this bandwidth moving online. But the problem that they don't know is that, a lot of people don't know, is that advanced compression uses 10x the compute power in order to do that. So if you take a file that's in H.264 today, and you encode it with X amount of CPU, and it takes X amount of time, and then you encode that same file using HEVC or VP9, it will take 10x the resources in order to do that. And the reason why that is because they look very, very deeply into each frame. H.624 is an 8x8 frame. VP9 and HEVC is a 64x64 frame. It's way more intensive as far as how deep they're going into the encoding stack. So 10x computing power is a lot. If you're looking to support these newer codecs and to move in the direction that everything's going, it's probably unrealistic that you're actually going to get 10 times the amount of encoders. Are you really going to go out there and buy 10 times the amount of encoders? Maybe, but most people probably aren't. And if you aren't ready to kind of make that just huge leap, then your current architecture is going to fail. You should get ready for an explosion. And the way that current cloud and on-premise solutions today work is they don't, and the reason why it's going to implode is because they don't efficiently manage resources. Now, a lot of people think that this isn't going to be a problem. This isn't a problem because we're moving to the cloud, and once we move to the cloud solves everything. But just because if you have software, and software is tied specifically to CPU, and it's tied to how that CPU is working, so it's in that engine, and you move that to the cloud, and it works the same exact way, you haven't really solved the problem. And if you look at this top part here, this is how current solutions are managed today in the cloud. You bring in a file, it's attached specifically to a cluster, one cluster or a server, and that server then encodes that and into different ABRs, and then it's stored in your storage and goes to the CDN. That's the exact same model as the hardware model that so many people have deployed in their own data centers today. It's still software and an encode specific to one cluster or one server. And that's exactly the problem. The encoding solutions of the future that are going to solve this are going to do horizontal parallelization and going to be able to take a single encoding job and break it into an infinite amount of different pieces and then stitch it back together on the back end. So you can literally take existing cloud resources, whatever they might be used for, and take all your encoding jobs and drop them on top, and they'll just automatically sift into all the empty CPUs and come out as efficiently as possible. And that's really what true cloud software is about. It's about how you manage resources. And it's not really about whether you have a UI that connects to something in Amazon. So here's a good analogy of how something scales horizontally. So when you're dealing with an H.624 type of solution, you have a pretty small file compared to the CPU that's available out there. So think of it as a small boat. One person, one computer can certainly encode H.264 at a variety of different bit rates very easily. But as you move to HEVC or VP9, that boat is huge. It's 10 times the size of the previous boat. So trying to use one compute resource in order to push that big boat becomes more of a problem. The way to effectively do that is to break that one huge file into a ton of different resources so that you have the proper amount of people paddling in order to get that thing encoded quickly. Bitmovin's a company that started in the cloud, and that was our core innovation, is the ability to manage resources better and to horizontally distribute the stack. And that ability is a huge advantage the way things are moving. One of the features that we get out of that is speed. If you take even an H.624 file that's 60 minutes long and you try to encode that through something like Zencoder or encoding.com that uses this parallel approach, it takes a long time. It can take an hour, it can take maybe a little bit under an hour, but it takes some time. With our approach and the way that we distribute horizontally, it takes 12 minutes just with the same exact stack that we have that's running in our SaaS solution. And if you work with a performance engineer to fine tune your cluster to get the best results, you can get that down to a minute or 2 minutes, depending on how big the cluster you want is. And right now, we don't see a lot of use cases in which speed is really a big issue, but as we move towards these huge files in encoding, this is going to become a major problem that you're going to need to address. In addition to speed being one of the core advantages, we also see the flexibility that's being driven out of that as being a big advantage. So a lot of people today want to take their encoding stack, they want to put part of it in AWS, they want to put some of it in Google, and they have their own cloud resources that a lot of IT departments and large corporations are building up. So they want to put as much of the encoding stack as possible in their own IT, and then they want to burst into either our cloud or their cloud or wherever it might be. But in order to do that properly, you need to have cloud software that natively distributes loads and knows how to bring them back together in high quality. We've done that from the very beginning. So initially we built our encoding stack for that. It's native to our product. So the ability to work in these kind of highly complex and flexible environments is something that we do really easily. Currently today we work in Amazon, Google, and Microsoft, and any environment out there that supports Docker and Kubernetes, which is what a lot of the internal IT groups are deploying these days. So the interesting thing about that is all of that connects back into the same API infrastructure. So regardless of where you manage our encoding stack, it's all connected back to the same API and it's all managed via the same SaaS. So you're able to maybe start with a relationship in Amazon, move to a split relationship with two different clouds, pull some things back in-house, and none of it will change from an API and a workflow standpoint. Your workflow will stay exactly the same. And that's what true cloud and true SaaS is really all about. It's about efficiencies in workflow, efficiencies in resources. So here's an example of a hybrid cloud, encode daily workloads, burst, however you want to do, nothing changes. So really, what is Bitmovin all about? We're really key, the co-founders are the co-creators of the MPEG- standard. They moved on to create serious innovations in cloud encoding, like the massive parallelization. and we provide a variety of web infrastructure products for video. So we are not an OVP, we do not provide retail video solutions. We power people that want to provide high-end video solutions. So we are an API provider that supports developers in the types of solutions that they want to deliver. So we have market-leading support. Currently we provide things like AVR. We already even have support for AV1. Extremely modular, very flexible, supporting the developer as they want to build their products. And a key tenet for us is providing world-class support and premium support for the folks that want to do these complex solutions. That's all I have today. Tired of waiting? Use Bitmovin. All right, thank you very much, everybody.